Cassini's radar pass did not fail when the islands appeared. It failed when they vanished from the map while the sea stayed unchanged. In the mission feeds at NASA's Jet Propulsion Laboratory, Ligeia Mare on Titan looked consistent for years. A dark methane ocean shaped into clean geometry by repeated orbital scans. Then one pass changed everything. Bright clusters formed inside the liquid, sharp, solid-looking reflections where there should have been only smooth sea. Radar does not guess, it records what returns energy. And what returned that day broke the expected behavior of an entire world. Within hours, the next scan erased them. Same coordinates, same region of sea, completely empty again. No trace of disturbance, no residue. Yet the earlier pass still sat in the archive, unchanged, official, and impossible to dismiss. Engineers reran processing chains, adjusted calibration models, and checked for compression artifacts. Nothing aligned. If the radar-bright islands inside Ligeia Mare were real, Titan's lakes were not stable surfaces. They were changing between observations. And that created immediate pressure. Navigation models depended on those maps. Future mission planning depended on them even more. A sea that could rewrite itself between flybys meant no baseline could be trusted for landing trajectories or orbital interpretation. But at first, the explanation stayed procedural. Noise, angle effects, signal distortion through liquid hydrocarbons. Each attempt to correct the image made the islands behave worse. In some reconstructions, they sharpened. In others, they fractured into multiple clusters. And then, on a later Cassini pass, the radar-bright islands inside Ligeia Mare returned again. Not identical, but unmistakably in the same region, as if the sea remembered where to contradict itself. That was when the interpretation began to shift. The problem was no longer whether the instrument was wrong. The problem was what the instrument was consistently showing. Titan's methane sea was not acting like a still basin. It behaved like a surface that changed state between observations, a place where radar could freeze a moment that no longer existed. Still, the official models resisted collapse. Seasonal methane cycles. Wind-driven wave interference. Subsurface convection bringing material to the surface. All of it sounded reasonable in isolation, but none of it explained the core contradiction. Solid-looking radar returns appearing in liquid, then disappearing without physical trace. The islands were not stable objects. They were transient structures inside the measurement itself. And then a pattern appeared, not in geography, but in timing. Every new Cassini pass added another frame, and each frame carried a version of the radar-bright islands inside Ligeia Mare that obeyed no consistent environmental rule. They appeared only under certain viewing angles, then vanished when the geometry shifted. For a short period, this created comfort. A working theory formed. Methane ice rafts, forming and breaking apart too quickly to persist. For a moment, that explanation held. It matched temperature models. It matched energy input calculations from Titan's weak sunlight. It gave the illusion of predictability. The sea was dynamic, but still physical, still obeying known rules. Then the next orbital sequence broke that stability. The same region produced islands under conditions that should not allow formation, and failed to produce them under conditions that should have guaranteed them. The prediction layer collapsed. The radar-bright islands inside Ligeia Mare were no longer responding to environment alone. They were responding to observation timing itself. That changed everything inside the analysis teams. Cassini data was no longer just mapping Titan, it was interacting with it. The islands appeared tied to when the spacecraft looked, not just what was there. Every pass created a different version of the sea. Every departure removed it again. The surface stopped being a passive object. It started behaving like a system that only existed in partial exposure. NASA analysts began to treat Ligeia Mare differently, not as incorrect data, as unstable representation. The maps were no longer fixed geography. They were time slices that could not agree with each other. Each pass contradicted the last without resolving into a single truth. And in the final interpretation shift, the radar-bright islands inside Ligeia Mare stopped being treated as land or ice entirely. They became a measurement boundary effect, a response generated at the edge between instrument and ocean, something that existed only when observed under specific conditions and dissolved when those conditions changed. The consequence was not just scientific confusion. It was structural. Titan's lakes could no longer be mapped as static terrain. Future missions would have to treat visibility itself as unstable. Not just the world changing, the act of seeing it changing what was seen. And when the first radar image is revisited now, it no longer looks like an ocean with islands. It looks like a system revealing and hiding itself in rhythm with being watched. The sea did not stop being a sea. It stopped being silent. The ocean was watching back.